Hello everyone, in this video I'm going to talk about similarity measures for categorical data. Euclidean and Manhattan distance measures are suitable for numerical variable. When we are dealing with categorical variables, we rely on matching coefficients and Jacquard's coefficients. Matching coefficient for a categorical variable is based on matching values to determine similarity among observations. The matching coefficient between the observations is the ratio of number of variables with matching outcomes and total number of variables. Now I have an example here. In this example, you see the list of college students, and each record shows the student's major, field, sex, and whether the student is on the dean's list or not. So there are three possible pairs between the students here. We can compare student 1 and 2, and then 1 and 3, and 2 and 3. Now let's start with comparing student 1 and 2. So when you look at the measure, the first student is in business, the second student is in engineering. It's not a match. Field, MIS, electrical, not a match. Sex, female, male, not a match. Dean's list, both of them are on the dean's list, so it's a match. We have 4 variables and only one is matching. Therefore, the matching coefficient is equal sign 1 over 4.25. Now let's do that for the students 1 and 3. Major, business, it's a match. Field, MIS, accounting, not a match. Sex, female, it's a match. Dean's list, yes, no, it's not a match. So we have 2 out of 4 outcomes matching. Therefore, matching coefficient is 0.5. And between students 2 and 3, major, engineering, business, not a match. Electrical, accounting, not a match. Male, female, not a match. Yes, no, not a match. So we have 0 over 4, 0 matching outcome. Based on the matching coefficient for these 3 students, students 1 and 3 are the most similar to each other, whereas students 2 and 3 are the most dissimilar. So this is how we calculate matching coefficient for categorical variables. Next, I'm going to talk about Jacquard's coefficient. We have one problem with matching coefficient. The matching coefficient makes no distinction between positive outcomes and negative outcomes. Therefore, it may provide a misleading measure of similarity. Consider, for example, consumer purchasing behavior at a grocery store when you have 4 products. So let's say products are ice cream, organic apples, cigarettes, and then beer. So let's assume we have 2 customers, A and B. Customer 1 buys ice cream, so it's a yes, and the others are no. Consumer B buys only organic apple. So here, when you calculate the matching coefficient between customer A and B, you are going to say, okay, here we don't have a match. Here we don't have a match, we have a match, we have a match. So you're going to end up saying 2 over 4, which is 0.5. These 2 customers buying only one product, one of them is ice cream and the other one is organic apple, may indicate that these 2 consumers are not similar. However, a simple matching coefficient will account for the fact that neither of the customers purchased the remaining 2 other products that are available and therefore erroneously produce a high value of the matching coefficient. Jacquard's coefficient is going to correct this problem. Jacquard coefficient is more appropriate measure of similarity in situations where negative outcomes are not as important as positive outcomes. So Jacquard coefficient is calculated as number of variables with matching positive outcomes divided by total number of variables minus number of variables with matching negative outcomes. On the screen, you see a retail store data. And this retail store collects point of sales information that shows whether or not 5 products were included in each sales transaction. A yes indicates a positive outcome, and no indicates a negative outcome. For example, transaction 1 indicates that a customer purchases a computer keyboard, a mouse, and a headphone. First, we will calculate matching coefficient and then Jacquard's coefficient between possible pairs of observation. So we have 4 transactions, therefore we have 6 possible pairs. Pairs between 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. Let's start with 1 and 2. First transaction, keyboard, yes, yes. So no, yes, it's not a match. Yes, yes, it's a match. No, no, it's a match. And headphone is not a match. Therefore, we have 3 matches out of 5, which is equal to 0.6 matching coefficient. Let's calculate now Jacquard's coefficient. For Jacquard's coefficient, we only look at for positive outcomes. Yes, it's a positive outcome. Yes, it's a positive outcome. No, it's not a positive outcome. Therefore, we have two positive outcomes divided by total number of variables is 5 minus the number of negative outcome is 1. Therefore, this is 2 over 4, which is equal to 0.5. And now let's calculate the remaining transactions using Excel. Here between 1 and 3, we have SD card match, we have USB drive match, and we have headphone match. Therefore, it is 3 over 5. And now for Jacquard's coefficient, SD card is a negative match and USB drive is a negative match. Only headphone is a positive match. So we start with 1 divided by 5 minus, we have 2 negative matches, 2, which is equal to 0.33. And now between 1 and 4, we have keyboard match, SD card match, USB drive match, 3 over 5, 0.6. And now let's calculate the Jacquard's coefficient. We have one positive match between keyboard, one negative match SD card, and one negative match USB drive. Therefore, it's 1 over 5 minus 2, which is 0.33. Between 2 and 3, we have one positive match divided by 5.2. And for Jacquard's match, we have one negative outcome and there is no positive outcome. Therefore, it's 0 over 5 minus 1, which is 0. And now between 2 and 4, we have 3 matching. That's why it's 0.6. For Jacquard's, we have one positive and 2 negative outcomes. That's why it's 5 minus 2 and it's 0.33. For the last one, we have 3 matching. And for Jacquard's, we have 0 positive matching, but 3 negative matches. That's why it's 0. Let's summarize our results. For transactions 1 and 2, we have the highest coefficient for Jacquard, implying that these transactions are most similar. However, you can realize some notable differences here. For example, the matching coefficient yield a higher value when comparing transactions with matching negative outcomes. For example, transactions 1 and 3, transactions 1 and 4. The absence of particular products in a sales transaction, which are negative outcomes, is usually not as important as the positive outcomes, and including the negative outcomes in the similarity measure is misleading. Consider transaction 3 and 4. The fact that the customers didn't purchase the same 3 products, memory card, mouse, and USB drive, may not imply any similarity between the 2 transactions or customers at all. Jacquard's coefficient makes the appropriate adjustment, and Jacquard's coefficient suggests a 0 similarity between these 2 variables, whereas the matching coefficient results in 0.6, a high similarity measure.